The Newton-Raphson method, also called the Newton method, is a great way to find the roots of an equation. It's like figuring out where the function crosses the x-axis. Sir Isaac Newton and Joseph Raphson came up with this, hence the name. The method is particularly useful for solving equations of the form fx equal to 0. The basic idea behind the Newton-Raphson method is to start with an initial guess for the root 0 and then iteratively refine that guess until you get a really accurate solution.
Hi, my name is Anis. Here I will explain how Newton method works. First, the geometry behind Newton method is shown in figure 2, where the root that we are trying to find is level r. The idea behind Newton method is that the tangent line is close to the curve, and so its x-intercept x2 is close to the x-intercept of the curve that we are trying to find, which is r. Because the tangent is aligned, we can easily find its x-intercept. To find a formula for x2 in terms of x1, we use the fact that the slope of L is f prime of x1, so its equation is y minus f of x1 equal f prime of x1 of x minus x1. Since the x-intercept of L is x2, we set y equal to 0 and obtain 0 minus f of x1 equal f prime of x1 of x2 minus x1. If f prime of x1 not equal to 0, we can solve this equation for x2, which is x2 equal to x1 minus f of x1 over f prime of x1. We use x2 as a second approximation to r. Next, we repeat this procedure with x1 replaced by the second approximation x2, using the tangent line at x2 f of x2. This gives a third approximation, which is x3 equal to x2 minus f of x2 over f prime of x2. If we keep repeating this process, we obtain a sequence of approximation x1, x2, x3, x4, and so on, as shown in figure 3. In general, if the n approximation is xn and the derivative of them is f prime of xn not equal to 0, then the next approximation is given by, which is xn plus 1 equal to xn minus f of xn over f prime of xn.
The formula associated with the Newton-Raphson method is... Now I will explain how the formula created. It's where function xn is the value of the function at the current approximation. Xn is the current approximation of the root. Xn plus 1 is the next approximation of the root. This iteratively improves your approximation of the root by using the slope of the tangent at the current point to estimate the next point where the function crosses the x-axis. F prime xn is the derivative of the function at the current approximation. This formula iteratively improves the approximation of the root by using the current approximation and the slope of the function at that point.
So for the first equation, as you can see, the equation said determine the root for fx equal to 3x power of 2 plus 2x minus 4 and give answer in 3 decimal places and assume the first approximation as 1. The first step that we need to do is differentiate the fx. 3x power of 2, when differentiate we get 9x. For 2x, when differentiate we get 2, and for 4, when differentiate we get 0. So we don't need to write that. And for Newton-Raphson, we need to use a table that have n, xn, fxn, f apostrophe xn, the differentiate one, and fxn plus 1. To get that, we need to use the formula fn minus fxn divided by f apostrophe xn. In the equation said, assume the first approximation as 1. So 1 under xn column, and to get fxn, you need to use fx equation 3x power of 2 plus 2x equal minus 4 and replace the x to 1 and you will get the answer is 1. And for the f apostrophe xn, the differentiate is 1. The differentiate one, do the same method, just replace the x to 1 by using the f apostrophe x equation and you will get 11. And for the last column, to find f xn plus 1, just use the formula that you see in the table, which is fn minus fxn divided by f apostrophe xn. And for the fn is 0 minus with fxn is 1 and divide by f apostrophe xn is 11 and you will get the answer is 0.909. Continue to the Newton-Raphson to get the answer. take the last answer back the fxn plus 1 and write it back under the xn column. And for the fxn, just replace the x in the equation with 0.909, just the same as f apostrophe xn. Just replace the x with 0.909 using the equation which has been differentiated, which is f apostrophe x. And for us to know when it's time to stop, we need to look at fxn plus 1. If you get the final answer that is the same as the previous one, we can stop the calculation right there. If not, you need to calculate until you get the same answer like previous. And that's all from me. Thank you.
Hello everyone, my name is Fatihah. Today I will explain to you step by step to solve question 2. Determine the root for function cos x minus x squared. Give answer in 3 decimal places. Assume the first approximation as 1. Step 1. We need to differentiate the given function. So we get f prime x is negative sign minus 2x. Step 2. We need to change calculator mode into radian. This is applicable only for solving trigonometric function. Press shift, then press setup, then press 2 for angle unit, and press 2 to set radian. Step 3. Form a table that have 5 columns as shown. N, xn, fxn, f prime xn, and fxn plus 1. Step 4. Write the formula. Then let A denote fxn equal to cos x minus x squared, and B denote f prime xn equal to negative sign minus 2x. Then type in this equation form in calculator. A equal to cos x minus x squared colon B equal to negative sign minus 2x colon x equal to x minus A over B. Step 6. Complete the table until you get a repeated value at fxn plus 1, the last column. From the table, we will get 0.824 is being repeated at the last column. So, we can stop the calculation. Therefore, the root for function cos x minus x squared is 0.824. Done!
Assalamualaikum warahmatullahi wabarakatuh. My name is FARZANA binti ABDULLAH and I will present about Newton-Raphson method conclusion. The Newton-Raphson method is referred to as one of the commonly used techniques for finding the roots of given equations. It can be efficiently generalized to find solution to a system of equations. Moreover, we can show that when we approach the root, the method is quadratically convergent. The approximation obtained using the Newton-Raphson method has a quadratic convergent rate if the initial guess is close to the solution. It is advantageous as a solution converge within a few iterations and save time while solving large system of nonlinear equations. Due to this reason, many finite element analysis software use this approach. Due to its easy-to-use formulation, it can be generalized to solve nonlinear equation, and it is nowadays used in software engineering. And that's all from our group. Thank you.